The Independence Day celebrations continue here on the morning show as the wise guy shows us his version of the rocket's red glare.
And to avoid blowing up the studio, we've sent the wise guy outside for today's experiment. Matt Sellen joins us live from his lab in Urbana. Hey, Matt.
Hey, guys. That was a wise choice sending me outside, actually, because we're going to do some smoky stuff and some sort of explosive stuff here in a second. So, as it turns out, today is actually Independence Day. If you think about it, it turns out that the original resolution of independence was signed on July 2nd in 1776, and then afterwards, 2 days later, they signed the Declaration of Independence. So I learned that because I became an American citizen a couple of years ago, and we had to study up on American history, so I'm very patriotic, and I thought I'd pass that along to you. So anyways, the first thing we're going to do is talk about rockets. And so on the website, I posted the question, how does a rocket work? And it's Newton's third law, really, and I had a few good answers, and in fact, Will Givens, of course, sent in the best answer. And so here it is. I have a little rocket that I got at Slot and Wing. This is a water rocket, whoops, and it's spraying water on me, as you can tell. So right now, I've pressurized the top of this thing. There's some water in the bottom, and when I let it go, hope I didn't get the camera too wet, what happens was it went poofing up in the air by Newton's third law. We had stuff being pushed down at the bottom, a force forcing the water out the bottom, forced the rocket to go upward. And as it turns out, the thing that's very important when you send up a rocket is the stuff that comes flying out the bottom. And so what you want to do to have the rocket go fast is to make the velocity of the stuff that comes out the bottom as high as you can. And you want to make the rocket as light as you can. Okay? And so I have here a bigger water rocket that I've been pumping on all morning here. So it should go pretty high. And so this is a 2-liter soda can or a pop bottle. And I pumped it up to about 60 or so PSI with a bicycle pump, and I'm going to let this one go, and we should probably move back because I bet it's going to spray water all over the place. I lost one of these in the tree in my backyard yesterday, so I had to make this one in kind of a hurry. And so I'm just going to make sure that we have pressure. We do. When I pull on this rope, it's going to go. So on the count of 3, 2, 1, 3, 2, 1.
Whoa!
Oh, well.
Oh my gosh!
It just came down.
Made a basket.
I almost got it in the garbage. That was pretty good. And what happened to the one in my house is it ended up in the top of my walnut tree. So that wasn't very good. But the kind of rockets you're used to seeing in the 4th of July kind of celebrations, the kind we'll see on Friday night out by the Memorial Stadium, are the ones that contain explosives in them to make them go up. And so I have here a little bottle rocket, and this is the kind of thing that when you light it, it goes up in the air and then it goes pop. Mm-hmm. And what I've done here, just so you can see what happens with this thing, is I've clamped it to a vice grip, and so it's not going to go anywhere. So you're going to have the chance to see what a rocket does when you're actually watching it do its thing. So I'm going to light the fuse here and step back, and then we can zoom in on it, and you'll see the stuff shooting out the bottom, which is the fuel and the hot exhaust going out very fast. A little while later, it's going to go kaboom, because that's what 4th of July fireworks do. So let's go like this. There we go. Better stand back a little there, Scott.
There it goes.
Kaboom.
So that was pretty good. And so it's this sort of stuff that we're going to talk about in the second segment. I've got a whole bunch of stuff from the chemistry department. I got a lot of help from Jesse Miller over there and Lauren D'Onofrio, who helped me put together some chemicals to illustrate rockets and explosions and oxidation, which is a chemical term for everything that goes on from rusting to burning to blowing up. And so we're going to talk about that in a few minutes.
The chemistry guys and the physics guys getting together.
Yeah, you never know what's going to happen when that happens.
It's a fun morning. Hey, Matt, love your shirt. That is
Very
so
cool.
patriotic. Yeah.
I love it.
Yeah. All right, we'll check back with you, and we'll learn a little bit more about these explosives that we're going to be watching on Friday night. Thanks, Matt.
Still ahead on the morning show.